the rest of this section of 9.6. Okay, mutually exclusive events. We're going to talk about the formula for that and what that means. Okay, so when A and B have no outcomes in common, they are considered two events A and B from the same sample space are mutually exclusive when they have no outcomes in common. The formula that we use for mutually exclusive events would be as follows. The probability of A union B, so A union B is what they use it for, equals the probability of A plus the probability of B minus the probability of A and not B. Okay. If A and B are mutually exclusive, then the union of A and B is simply the probability of A plus the probability of B. Because the probability of both of them not happening would be 0, so you would be subtracting 0 from it. So they just simplify the formula. Okay? So, one card is selected at random from a standard deck of 52 playing cards. What's the probability that the card is either a heart or a face card? How can you figure that out?
Mentioning two separate equations.
Sort of.
Yeah, 1 in 26 of falling a black, or 26 out of 52, you fall a red or black card.
Sort of. You're almost on the right track. So because it's asking what's the probability that the card is either a heart or a face card. So not 26 out of 52.
You have to add the other 8.
It's 13 out of 52 because hearts are only 13 cards.
Soup, okay,
Yeah.
not red.
Not by red. So the probability of A in this case is 13 out of 52. What would be my probability of B in this case, of pulling a face card? How many face cards are there in a deck of cards?
16.
4,
16.
Wait, what are you talking
What
about?
times 4?
What was the question?
16.
There's 3 face cards, Jack, King, Queen.
And
12.
So 12.
Ace. Oh, the
Ace is not that. So you have 12 out of 52, okay? Now, here's the deal. How many of those cards overlap? Are both face and heart cards? 3. 3 out of 52. So, probability of it being A is 3 out of 52.
Wait, why is it 3 out of 52?
Because those are the ones that overlap. They're both face and heart cards.
Oh, okay.
Okay? And so then we just set up this formula right here for the union of A and B. And we're taking away the probability of the overlap so that we can figure out the probability of the real thing. So you have probability of A union B equals 13 out of 52 plus 12 out of 52 minus 3 out of 52. So 13 and 12 is 15, right? And then 15 minus 3 is, like, it's not
It's
15, it's
25.
25,
Yeah.
thank you. It's 25, and then 25 minus 3 is 22. So we get 22 out of 52. How does that reduce down? Both are divisible by
11.
2, so you get 11 over 26. And so percentage-wise or decimal-wise, that probability of 11/26
0.42.
is 0.42. 2. So your probability of pulling,
Of what?
Either-
Wait, of what?
the probability of pulling either a heart or a face card is a 0.42%.
Say if it's going like that.
It's a pretty decent percentage
Yeah, it's probably pretty good.
for pulling one or the other. It's almost 50%.
But if you were to take the base like that,
Then it would be, just 1/4 of the probability, yep. Okay. So that is when events are mutually exclusive. When they're exclusive, we subtract what the overlap is, okay? We take the probabilities of both individually and subtract the overlap. Sometimes the overlap is 0, okay? Sometimes they draw it this way. So if we had drawn this out in circle form, we would have gone like this and like this. And we would have said 13, hearts. You would have said 12 face cards. And then we would have known that 3 overlap here. That's how we get those fractions. And we're just taking away the overlap so that we don't count this twice in what we're doing. If the overlap is 0, that means I would have 2 individual circles like this, and my overlap would be 0 that I put here, which is how we get that formula. They're the same formula. Okay? Meaning, they could say, what's the probability of picking a heart, and what's the probability of picking a club, okay? And so those are 2 separate events. Nothing overlaps between those 2. Nothing's the same of those 2. Okay? And so then our subtracting of it would be 0 because there is no overlap. Okay. An employer is chosen at random. What is the probability that the employee has 4 or fewer years of service? And I'm gonna give you a chart. So, let's say this. 0 to 4, 157. 5 to 9,
That makes it okay.
89. 10 to 14, 74. 15 to 19, 63. 20 to 24, 42. 25 to 29, 38. 30 to 34 is 37. 35 to 39 is 21. And 40 to 44 years is 8. This is years of service. And this is number of employees.
Wow.
Okay, which it should go down as you get higher up because people should be
40
retired.
years of people, oh my
Yes, crazy, right? So, it wants to know, for question A, it says, an employer is chosen at random, what's the probability that the employee has 4 or fewer years of service? So, 4 or fewer. 4 or less years of service. How can I figure out that probability?
I'm gonna add all of them up, like all of them.
All the
Employees.
employees, okay, so we need to add up all the employees. What happens when we add up all the employees?
Do that in your head, and it's 157 over that.
8 plus 21 plus 3. So you should get 529, right? And then you said it's 157 over that?
Mhm.
And you would be correct. Equals 157 over 529. So that's a probability of A. Now, B says 9 or fewer years of service. 9 or less. So what do I have to do there?
You gotta add 89 plus 157, which is 246.
Add 89 and 157,
Yeah, so it's 246 over 5.
so it says 9 or fewer years of service.
Oh, 9 or few, yeah.
Okay, so you wanna add 89 and the 157. So if we just take this category right here and have it represent the probability of B, you have 89 over 529, right? And so if I take 157 over 529 and I add 89 over 529 to it, because they're exclusive from each other, I will get 246 over 529. And that probability would then be 246 divided by 529. Basically 0.47 if I rounded to 2 decimal places. So basically 47% of this company is made up of people that have 9 years of experience or less.
Wow. Interesting. What a company.
What a company. Well, logically, that does make sense now,
Hmm.
because they're gonna hire more young people because they're cheaper.
Right, actually, yeah.
No one's hiring me.
Now, the last thing we need to talk about is independent events.
Ben's not coming in today.
He just said he was on his way.
No, he was, I guess he was driving somewhere else, he just texted me.
Independent events.
God.
Okay, independent event is basically when the outcome of one has no effect on the occurrence of the other. Outcome
7 minutes.
of one has no effect on the outcome of another. The probability for that, if you see the word "and" in a word problem, you're probably using independent, because it's the probability of A and B, meaning it's the probability of A times the probability of B. Okay? An example would be like this. A random number generator on a computer selects 3 integers from 1 to 20. What is the probability that all 3 numbers are less than or equal to 5? Okay, less than or equal to 5. Well, how many total numbers are being selected? Well, let's see. A random number generator on a computer selects 3 integers from 1 to 20. What's the probability that all 3 numbers are less than or equal to 5? So the probability of it being 5 is 5 over 20, correct? Okay. And it wants to know, it says that it's selecting 3 total numbers and they want them all to be 5 or less. So choosing 5 or less is 5 over 20, which is 1/4. So the probability of A and B and C, picking numbers 1, 2, and 3, equals 1/4 times 1/4 times 1/4. 4 and 4 is 16, and 16 times 4 is 64. So you have a 1 in 64th chance of picking 3 numbers in a row that are less than 5 on the number generator. So they're gonna ask you questions like that deal with independent things. That is the rest of 9.6.